Today we're going to look at LeetCode 1357, apply discount every n orders. So this is a novel to read through, and it's not the best English, but we'll work through it. So let's start with the description. There is a sale in a supermarket. There will be a discount every n customers. There are some products in the supermarket where the ID of the ith product is product I, and the price per unit of that product is prices I. And it says the system will count the number of customers, so it's going to keep track of how many customers we've hit. And when the nth customer arrives, they will receive a discount on the bill. And they give that formula there for the discounted bill. So X would be the final bill price, and this would be the discounted bill price. And then it says it resets the counter, and it starts counting customers again. So it says the customer orders will contain a certain amount of each product, where product I is the ID of the ith product the customer ordered, and amount I is the number of units the customer ordered of that product. And it says implement the class. So we're given a constructor. That's going to be kind of our initializer. We're going to be saving all this information, and a counter as well to keep track of how many customers we have, and then they're going to call this function here getBill over and over and over again. So there's a these sort of system design questions, the examples are very tough to read through. You can't really get much out of them. I'd recommend just repeating the description until you have a better grasp of it. Let's look at the constraints. So in the number of customers per discount is a relatively small number, 10 to the 4. The discount itself is pretty small as well. We don't have to worry about crazy sizes. The number of products is small. The IDs themselves, that's this one here. The IDs are pretty small, 1 to 200. We don't have to worry about overflows or anything on that. There's no repeated elements, so this is like a corner case. So the majority of these constraints are like edge cases that you should be thinking about and asking in the interviews. So like, okay, we're given a products array. All right, are there repetitions? Is there going to be, could it be null? Could it be empty? Do products and prices have the same length? That's something we could validate against too. And we see here prices.length equals products.length, so that's basically saying no, you don't need to check that. That's already given. So basically it's a pretty safe problem. There's not much edge casing or validation that we need to do here. And there's not really worrying about overflows here. This last one here, whenever you see something like this, within X amount of the actual value will be accepted as correct. That's just because we're going to be using floats, right? We have some division here. Whenever you have division, you may get a decimal result, right? You might not get an integer. So that's all that one's saying. Okay, so let's copy these over, bring them over. Let's work on just designing cashier first. So what do we need to keep track of? We need to keep track of n, the number of customers per discount. So n is an integer. We don't need that. We need to keep track of the discount amount, which is also an integer. And let's think about this. So we do need to keep track of what products and their prices that were given. So they give us an array of products and an array of prices. So the products, this array is an array of IDs here. So it's like this. Think of it like this. So you have your products. Let's just say that's this array, 1, 2, 3, 4, 5. So these are IDs. This is an array of IDs. And what it's saying is you also have prices. And this is an array of dollar. Think of it as the dollar cost of each of the products here. So for example, the product with ID 123 has a cost of 55. the product with the ID 555 has a cost of 12, and so on. So just off the bat, I'm seeing a hash map is a good way to keep track of these. So in Golang, we can toss that in. So I'll call it price map, and we're going to say that's a map of integers. And so it's a map with integer keys and integer values. So the product IDs themselves are integers, they're only integers, and the prices themselves are only integers. So that's why we choose this map. This map's kind of like product ID, and that maps to the price. Product price. Okay, so that's kind of what's going on here. So we give it the key, which is the ID, and we get the price back. This is going to be useful later. Okay, is there anything else we need to keep track of here? Products, prices. Okay, we need to keep a running count of the customers, right? See here, the system will count the number of customers, and then the system will start counting customers again. So we have to have a customer count tracker, basically, and that's just an integer. And this is like a running count of how many customers. So when we hit n on a customer count, that's when we'd apply the discount, and then we'd reset this back. Okay, so let's say C is some cashier object. Let's fill the fields. So n is just whatever they give us here, n. The discount is going to be just whatever discounts passed in. So products. Okay, so this one, let's just initialize this. But oh no, what did I do? All right, so let's just leave that alone. Customer count, that's fine. Let's just have that start at 0. Okay, so now we have this, and let's return it at the end. All right, so everything's happy now. Now we just need to initialize our price map. So we need to go through the products, and we need to map them to their prices. So let's say for I, V, and range products, and let's say C.priceMap. C.priceMap, and we'll get the key, which is the value, and it's equal to the amounts, or the prices, at that index. Okay, so this is totally the same as well as this. These are equivalent statements. This is the key, the product ID here. The product ID is at product I, and the price for that product ID is at prices I. I'm just choosing to use this value here just because it's less characters. So we'll go with that. Okay, that's good. Okay, so I'm happy with the constructor for now. That should be in good shape. So let's move on to the get bill. Okay, so they're going to call this repeatedly, and basically we need to return a bill. So let's make some bill, and let's set it to 0, and let's return it. All right, so that's the simple life there. So what we're given here is a list of products. So when we call get bill, it's on one customer, just one customer. Okay, so we need to be keeping track of the customer count as well. So what we can say is if our customer count, we access it by c.customerCount, and we could say if it's equal to c.n minus 1, because we're starting at 0. Customer count starts at 0, so you always need to have that minus 1. If it's equal to that, then we want to apply our discount. So let's see, what's the discount formula? Bill is bill minus c dot. We need the discount, and let's put that as a float. Discount times the bill divided by 100. Okay, so that's the discounted bill. Yep, that's the discounted bill there, and then we can say we need to reset our customer count as well. So c.customer count is 1. Okay, so that's the case. If we've hit the right amount of customers, then we're going to apply our discount and reset the customer count. Otherwise, we're not going to worry about that discount. Okay, so let's set up the bill here. So we want to go through each product. Let's say we just have one product, right? So it would be that product ID. We'd use the product ID. We would use c.price_map with that product ID. So 1, 2, 3, for example. And then if we just had one of those products that we're buying, we'd multiply it by 1, right? But what if we have 5 or 3 or 2? So that's where the amounts array comes in handy. So let's iterate through our products for this customer. And let's say bill, we can just say plus equals, and we're going to say our price map with the key times the amount at that index. Okay, and this won't like it because this is going to be integers, so let's say float. So amount is an integer, and our price map is also just a bunch of integers, so we need to convert that to a float. Okay, so this increases our bill here, and we can run that all the way through. That's good. And then this here checks if our customer count is the correct number here. So let's see. Let's think about this. So we want to reset customer count to 0. Otherwise, we just want to increment it. So if we should apply our discount, what this is checking is, okay, should I apply my discount? If so, update our bill and then reset our customer count. Otherwise, we're not applying this discount, so we just want to increment our customer count. And then at the end, we're returning that bill. So let's bring this over. I think that's in a good state. And let's run this. I would not be surprised if we get some errors here. We'll see. Okay, so that did get accepted. Okay, so the main part, let's just walk through this get bill. I think the constructor is relatively straightforward. They're giving you information here. You're storing it in this struct that we designed to store that information. But let's walk through this get bill one more time here. So we start out with our bill, it's just empty. This right here, the work we're doing here is we are basically initializing our bill. We're saying for every product that the customer is going to buy, we need to add the cost of that product times the amount that we're buying to the bill. Okay, so after we've built up our bill, we've got the final bill, then we get on here to the customer count. We need to check, okay, have we reached enough customers that we start discounting here? So the system will count the number of customers, and when the nth customer arrives, they'll have a discount. So basically we're saying, okay, have we hit the nth customer? And the reason we have n-1 here is just because we chose to start with 0. Yeah, we chose to start with 0 up here. That's just preference. So if we do have the nth customer, they're arriving, okay, that means we need to update our bill and we need to use the formula they gave us right here. So X is just the cost, that's just the bill. And this is just following that formula they gave us. And in that case, we reset because it says then the system will start counting customers again. So we start over and we start counting from 0 again. Otherwise, we haven't reached the nth customer, so we just increment our customer count. And then finally, we're just returning the bill. So let's run one more time, double check I didn't accidentally change anything here. And then we'll try submitting. And let's think about the complexity for this here. This is just a single loop going on in here, so this is basically just on time complexity. The constructor is the same, basically it's on however many products we have, that's our n in this case, so it's just O of n for the constructor, and just O of n here on the get bill call. And for these system design questions, I'm not sure if they're going to ask about space complexity, but we can just think about, okay, we are using cashier struct, and what space are we taking up? Well, however many products we have, we're going to have an entry in price map. So the space would be ON as well for this whole system. So times ON and space is ON as well. And that is LeetCode 1357, apply discounts every n orders.